Welcome back. So we are at question 8b, and I've started this because it seems that we cannot write on Microsoft itself. So let's draw again. V is at an angle to the horizontal, right? And we know that the horizontal component, which we call Vx, is value, and the vertical component is Vy, right? So, and the original velocity is V. So we can write a few equations already just based on this. We can say sine theta is Vy over V, and cosine theta is Vx over V. And here, from the equation, or rather the question, we have seen, right, that sine theta is 3 over 5, so here's 3 over 5, and this should be 4 over 5. Okay. And they also use very nice numbers, which means that V itself, if we use the ratio, this should be 3, Vy should be 3, Vx should be 4, and V should be 5. Right? It's very nice ratios of a right angle triangle. So, we want the vertical component, which is Vy. So using this, we can say that Vy is 3 over 5 times V, and this gives us 0.6. V value is 7.0 times 10 to the power 6. So 0.6 times 7 gives me 4.2 times 10 to the power 6 meter second. Right, that be easily done. Right? So let's see. We now have the vertical velocity Vy equals to this value. Right? The next question, C part 1. In your tutorial question, it says B because you notice there are actually two part A, but to be correct, this should be C part 1. Okay? We are now asked to find the radius of the helical path. Okay, let's see what other information we need from the question before I zoom away. There's one more information that we know, or rather we need, is the flux. Density B equals to 3.14 times 10 to the power minus 5. So I wonder if the value being so close to pi is on purpose. Let's see. So right, we need to now look for the helical path. So remember just now, in the helical path, right, that we have, when we look from behind, we are observing a circular path, moving this way, right? This being Vy. And the V field is going into the edge, which I'll denote by a few crosses just at the edge. And we said that there's a force towards the center. Okay, there's a centripetal force. So just now I was halfway through doing it. The centripetal force is provided by magnetic field, the force due to the magnetic field. Okay, mv square over r, dy square over r equals to bq dy. Then we cancel this out and we rearranged, so this whole chunk becomes r equals to m vy over bq. Right, so all you have to do is to sub in the values of the electron. 9.11 times 10 to the power negative 31. The velocity Vy, which is 4.2 times 10 to the power 6. The value of B, 3.14, 10 to the power negative 31. Oh, sorry, 10 to the power 5, sorry. Negative 5. And the charge is 1.6 times 10 to the power of punch your calculator, bang, 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 and you should get your answer, right? So nothing too scary there. Right, so notice that the solutions here give 0.762 meters. That's pretty large for a radius. Here we have 0.762 meters. Okay. Let's go back to the question. What else? B or the C part 2. The time required for the electron to complete one revolution in the helix. So it is moving this way. Let me just do one part. So it's doing from here down and back up, right up to where the eye level is. So it's traveling like this. But this 2 point, when I come back, it doesn't connect. It's actually some distance further down. How do I find the time? There are actually a number of ways that you can do it. Right? You can find, given the velocity, given the radius, you can actually find, right, the circumference, and given the velocity, you can find the time, right? So one way, right, r goes to 0.762 meters. We know that the circumference is 2 pi r. Find a certain value. So since velocity is distance divided by time, or distance divided by time will just be this. Then we can just put 2 pi r over b, plug in the values and find the time. Right, so that's one way to do it. A more complicated way would be starting with this, Fc equals Fb. We know that Fc can be given mr omega squared equals to this v is vy. And we know that r omega is essentially v, so you get m v omega. And Vy omega equals to V. So Vy and Vy cancels out. And omega is 2 pi over T equals to Q. So T is just 2 pi m over BQ. This method that I have done here, right, is if C part 2 was the first question you encountered, you can still do it, right? Just to start from the very basics. Okay. So here again, the solution shouldn't be difficult. Just once you do either method, plug in the values, you should get your answer. So let's take a look at them. Scroll down. Right, there you go. C part 2, the time is 1.14 10 to the power of minus 6. That is a very small microsecond. Not a problem, right? C part 3, what's the question? The velocity component parallel to the field. That's a free 2 marks given to you, right? Because you've really proven, even if you couldn't do C part B, right? You know that this is 7. They already told you that the vertical component is 4.2, right? 10 to the power of 6. Using Pythagoras, you can even get this, right? Right, so there are many ways to get this. So here's cosine theta goes to Vx over 7. This will be Vx, the horizontal component. We are looking from the side of the spiral, according to the question. So, and cosine theta we know to be 4 over 5. So we just have 4 over 5 times 7, giving us Vx. So this is a strange 2 marks. Way easier to get compared to the other previous 2. Here we go. So V horizontal is V cosine theta. Okay, not an issue. Moving on. Pitch. What is pitch? Pitch is the horizontal distance covered on one revolution of the helix. Right? So you should start from the bottom, right? It's the one that is new to some students. One circle, that's the pitch. If you're looking from behind, if you're looking from behind, what would you see? You'll see the circle move like this. Right? So from behind is a circle, from the front is a helical path, and the pitch is the horizontal distance moved. So you have the time, right? You found the time to be 1.14 times 10 to the power minus 6. We have the horizontal velocity, right? So oops, Vx goes to 4/5, which I'm not going to use my mental sums here, but it shouldn't be that difficult. So it should be 0.8 times 7 should be 5.6. Let's see if I'm right. Yes, so it's 5.6. Velocity here is wrong. -1. So using this equation again, so the distance in the x direction must be the velocity in x direction multiplied by time. So this value multiplied by this value, you get the answer 6.38 meters. Okay.